It's MIS.
All right, camera's on. Y'all write that down. You got already. I'm gonna get
You're welcome, Ashley and Marisol.
What?
I know, you did Well, I don't know.
Speaker should be like cold.
Yes.
Can we put up a Christmas tree in here?
Yes.
Please.
Guys, let's put.
After, like, not yet.
Yes,
it's kind of dead.
Can we just decorate his whole room?
If I buy some lights and bring them, can you please? This is dead.
Yeah, Mr. Cato's Santa hat.
Isn't that cool?
Guys, we get a whistle. We get a whistle. And put it on the
Oh my
tree.
gosh, it goes so well on top of that. Yes. And we can only make ornaments for it. Can we please?
No, the
Guys,
owner
I'm gonna
should
make
have
a whistle and a referee.
Imagine you
Imagine.
made them like.
The star could be like the heat of the universe.
Oh, I was trying to explain that to my mom the other day.
What's
My
that?
mom, my brother, the heat death of the universe talk that we had
Uh-huh.
last year, and then I like forgot.
People are saying it's gonna happen August 12th,
So like I kind
2036.
of like halfway explained it.
No, the death of the universe will not be August 12th.
Yeah.
Could happen.
How do they know? How do they know? How do they know? No.
But
You're wrong.
you forgot how to explain it, or forgot what it was.
Well, I mean, I remember what it was, and then like I got halfway through explaining what it was, and then I realized that there were like huge gaps in the details that I was saying. And I was like, dang it, why don't I remember this part of the video?
Yay!
Right.
Yay! Matthew liking hard no messes again, still coming in here.
But yeah, I kind of like forgot half of it.
How was it?
Boring, terrible.
The elevator was.
I hope you didn't leave out the part about how it's like in the 100 years from now.
Oh no, I
Earlier
didn't,
was
I
not-
didn't say that part.
It was bad.
Yeah.
We was all trying to school.
Was it
Yeah, I saw
hot?
it. Greg took a picture of it.
Oh no, it was cold outside. Never mind, they
They
walked
have
in
a
the cold.
cold every single school.
No.
Is that what I was
No,
That was just for the library?
No,
13,
we
10,
told them stuff. They literally had us
same
go to
thing.
the expo, just to look at the campus. And that's it. We went to the rest of the library. We went back on the bus. Then we came back
I
up,
got
we
it
went
in
back on the
practice
bus.
today.
Y'all ate that?
Yeah, but the food wasn't even that good.
All right, y'all written that down, you ready? Here's what we're gonna talk about, separation techniques. And I'm gonna sort of demonstrate one of them. I'm gonna show you the apparatus for the rest of them. And that way you should be able to kind of get the gist, I think. We don't really have time to do every one of them. Most of them are pretty simple concepts, okay? All right, so we'll start with the easiest, kind of easiest to work our way down. So what we're talking about here are separating substances from each other, mixtures, maybe solutions, okay? So, as we discussed through the intermolecular forces, light dissolves light, is the saying that we use, right? Not going to be our answer on the test though, correct? We're not going to put light dissolves light. We're going to put that ethanol and water mix because they're both polar and both have hydrogen bonding, right? Okay, we're going to put that methane and pentane mix because they're both non-polar, like each other that way. We're not going to say that. We'll say because they're both non-polar, so they're visible, okay? But thing to remember, back of our mind, is light dissolves light. All right, so if you have several combinations here, let's just say that you have a mixture of an insoluble solid and a liquid. Okay, take I don't know, silver chloride and water. All right, so silver chloride is insoluble salt. If you think back to solubility rules, okay, so nitrates are soluble and first column metals are soluble. That's the two main things you remember. But chlorides, bromides, and iodides are soluble except for three exceptions: silver, lead, mercury. Right. So silver chloride the most common precipitate to show up on the AP exam. It would be like with 3 different questions that would have something to do with that. Okay, we use it over and over and over as an example. So silver chloride would be insoluble in water. So if you had a beaker of silver chloride in water, it's going to be settled on the bottom. Okay, how would you separate that? Well, you would just filter it. Okay, and there's several different kind of filter systems, but the simplest one is to take filter paper in a funnel. Okay, and you just fold the filter paper twice. Okay, and it makes a little triangle looking deal. And then you make yourself a little funnel. Okay, like arts and crafts day or something in chemistry class. So you make a little funnel, and if you wet it, it'll stick to the side, which makes it work a little better. But then you just made yourself a little filtration funnel, and you would take that and just pour it in there. And what's the water going to do? Passes through the paper, drips out the bottom. Okay, and where's the sodium chloride going to stay? In the funnel, right? So you would have separated the insoluble solid from the liquid. In our example here, it'd be silver chloride and water. It could be any liquid and any solid that don't mix together. Right? And you can separate them that way. This is the simplest version. There's ways to do it with a vacuum, to use some suction to make it go faster, because this is really, really slow. Okay, and I've got a, look back here for a second. We have some filtration flasks that are, so this little spout on the side, this would all go, you have to put a little rubber stopper on this so that it would seal. If you make that seal together, then you hook it to this hose here. If you turn the water on, not to get into physics too much, but if you turn the water on, the water flowing 90 degrees to this hose causes a vacuum. All right, so this would act, this is called vacuum filtration. All right, so you're going to get, that's going to basically just suck the water through. It's not physically correct. It creates a vacuum below the water, and the atmosphere pushes the water in. In the physics class, to break that down a little more. But either way, it makes it work a lot faster, but it's the same thing. This is just if you don't have an hour for that drip, drip, drip. That's pretty much what it does. It takes forever. If you just pour water through that filter paper, it's going to take a while. But if you pull it through, it's much quicker. But that's a filtration. Insoluble solid from a liquid. Again, there's different shaped funnels. There's different kinds of paper. They could give you some different descriptions on the AP exam or something. Okay, but the idea is it's filtration. Okay? If you need to separate a solid from a liquid, filter. Okay? Whatever kind of different equipment they might put in a list or something. You're looking for the filter paper, the funnels, that kind of stuff. Okay. All right. If you're doing a crystallization, so let's just say we had a, put it in a beaker, it doesn't really matter, but this is pretty simple. If you had a solid that was dissolved in a liquid, then you could evaporate. Technically, you can boil it. You would probably do it kind of slow. It's a little bit more of evaporation than it is a vaporization. But if you had a, let's say, this salt water solution, right, in this beaker, you just put it on a hot plate back there and let this get hot. Where's the water eventually going to go? There's a gas, and where's the salt end up? Is a crystal, right? So we call it crystallization. Sometimes it's called a recrystallization because the salt used to be a crystal. It got added to the water where it dissociated, right? And you're now recrystallizing it. So as that water leaves, those cations and anions are going to find each other and recrystallize together. So you'll end up with a salt, a solid salt, at the bottom of your little container, and the water will be gone into the atmosphere. And that's a crystallization, or sometimes called a recrystallization. You want to jot that down, just in case they use either term. It's the same thing. All right, distillation is, we've talked about this before. Distillation is separating miscible liquids that have different boiling points. So two liquids that are mixed together, okay? If they have different boiling points, they all have different boiling points, but using those different boiling points to separate them is called a distillation. So if we had water, for example, simplest example, we had water, a mixture of water and ethanol in here. okay? Let's just say we had some 100 proof moonshine in here, we wanted it to be a little higher, okay? All right, then we can put this on a hot plate over some heat. The ethanol is going to boil at about 78 Celsius. The water doesn't boil until you get to 100. So if you get this to a little above 78, about 80 or so, the ethanol is going to start boiling. It's going to vaporize and go up the tube. We'll have this sealed off, right? It's going to go up the tube. That's why you can't get it too hot. Because you get it too hot, you're going to blow something up. You just want it hot enough to vaporize, but you want it not be so hot that it gets that hot up here, because it's got to be below the boiling point up here. So your heat source is down here. Up here needs to be below 78. So you heat it, it vaporizes. When it gets up here, it cools, it liquefies, and as it's running back down, some of it's going to channel over here into this little spout, and you would catch it over here in another flask. Okay, a lot of it just runs back down in here and gets re-vaporized, but you just keep doing it until you get all of it to go down there.
So eventually,
Eventually, you've got it all over here. Most all of it. Ethanol and water sticks so well together that you can't get all of it. Some of those ethanols are going to drag water with them as they go. But some substances, if they're not that miscible together, can be separated. Water and ethanol don't separate perfectly because they are extremely miscible. Clean, it's called a dimer. The hydrogen bonding is so strong that it's almost impossible. Not quite. Really, really strong. All right. Side note here, and I don't even know what, you just call this a separation. So I guess I could have put that on the list. But just a separation is what organic chemists call this. But if you had two immiscible liquids, like hexane and water, okay, completely nonpolar liquid hydrocarbon with a polar solvent, they're not going to mix, okay? It's the oil and water don't mix concept, right? So if you had that and you wanted to separate it, you could put it in here, right? The least dense one will make a top layer. So there'll be 2 layers or 3 layers if you had 3 substances. Okay, usually it's just 2. And even if they're both clear, you can, if you look real close, you'll be able to see a little line between them. All right. If they get shaken up, sometimes you have to let it settle for a minute. You have to give it a little bit to let them separate out again. But the least dense one will eventually go to the top, and the heavier one will go to the bottom. And you'll be able to see a slight little line there. And then what this is going to do is drain off the one that's on the bottom. Okay, so you open that little valve, and it starts dripping out the bottom, and you just watch that little line drop. And then you can see when it gets here that you shut it off. And you pour it off. The lightest one has been poured off into something else, and the heavy one's still in. I got that backwards, sorry. The heavy one pours off, and the lighter one's still in. Okay? That makes sense. That's if they don't mix. If they're miscible, then you're just pouring them both out. Yeah.
You said they're both immiscible?
If they're both miscible,
Miscible?
then this doesn't work. You just pour them both out. That's all you do it. They have to be immiscible, and you have to be able to see a line, barrier. Solvent barrier? What's the name of that? Anyway, you can see it. Even if they're both clear. If they're different colors, it's really easy. It'll be like the blue one and the green one. But, you know, if they're both clear, most things are clear. Even if you look, you just look and you can see that separating. Okay. All right, the one that's a little trickier is called chromatography. And it separates miscible liquids with different polarities. So distillation separates miscible liquids with different boiling points. Chromatography does it with different polarities, okay? And these are a little more complicated. So we're going to see if we can demonstrate this one. I don't guarantee this works because I can't remember exactly the matchup of solvent to ink and all that. So if this doesn't work, we'll just try something else till the bell rings and then we'll give up. Get a couple of different colors here. So these markers have liquid ink in them, right? Okay, that has a variety of organic dyes in them that absorb electrons at various wavelengths, okay, and transmit electrons of other wavelengths that we can see different colors, right? Okay. This one's absorbing all the electrons, right? This is black, so it's got a mixture of dyes. They use a bunch of different dyes to make black ink. Basically, they got to find something that gets up everything. They got some that gets up the oranges and the blues, and some gets up the yellows and the greens, and all eventually you soak them all up, and you have black. Okay. This one's going to soak up everything but purple. Okay. And purple's going to bounce off, and then we see purple, right? Okay. So this may not have any. This may or may not be a mixture. It's got to be a little bit of a mixture because it's not like color the rainbow purple. So it's got to be a little bit of a mixture. Probably. We're going to see. So what you do with chromatography is you need a medium. A piece of paper will work. They make, if you're really in a lab and really trying to do this for real, you're going to use usually some kind of silica gel kind of stuff. It's a silicon-based, white, powdery looking stuff, okay? You mix it with certain compounds, it makes a gel type consistency. What you're doing is you're going to separate the mixture out based off of their attraction to the medium, which in our case is this piece of filter paper, versus its attraction to the solvent, which is going to be ethanol. Okay? So what we're going to do is we're going to put a sample of each of these on the bottom of a piece of paper. Just going to do two examples. We can do a whole bunch. I'm just going to do two right now. That looks black. And you want to okay. So we're going to put just a little bit of ethanol in the bottom of each of these beakers. Just a little bit in the bottom. You don't want it to be smudged that it drowns the sample. Okay. What's going to happen? We put this. We're going to dip this in here. We don't want the liquid to come above our sample. We want it to be down here. This paper is going to soak up that ethanol, and the ethanol is going to rise up through the paper. Okay. It's like dipping paper towel in some water or something. When it passes through this ink mixture, if anything in the ink is soluble in ethanol, it will take it with it. Anything that's not very soluble in ethanol, it will leave it behind. In other words, anything that's more attracted to the paper will drag behind. Anything that's more attracted to ethanol will come up the paper with the ethanol. Basically, you're going to take how many compounds are in here, and they're going to have a race. If you've ever watched a race, like a 100-meter dash, everybody starts on the same line, right? By the time they get to the end of the track, they're all spread out. Okay, and it's basically the same idea. So we're going to dip that one in here. That was the black one. This is the purple marker. We'll give it. Going to use take in a couple minutes. It's almost already baked. You can see. I'll come look at this one. It's just fine paper. It's dramatic. I said I don't know if we'll see a separation or not. I couldn't remember exactly which marker to use with ethanol. But purple one's going with it. Purple may not even be a mixture. I'm not even sure. I know black is a mixture. I just couldn't remember which solvent you use with Expo. There's different markers. You use Sharpie, you use different brands of marker, and they all have different compounds. Black not really go anywhere. Okay. Anybody got a Sharpie?
Yes.
Black Sharpie?
Yes. I'm pretty sure.
You go cut another piece of paper down. Yeah.
I'm not really sure what that part is either. great picture, by the way.
Slave. Do anything dramatic?
Purple. Purple is.
Black's not, just try the sharp. Nope. Let's put a little more alcohol in there, so it's not that. No, this is not drinkable alcohol.
Okay, good to know.
It says denatured on the side, right?
Is that like sending
Cannabis
another
will kill you.
That's sending another
No, this is ethanol, but it's been denatured, which means it's been poisoned.
Oh,
It's got probably a couple percentage points of methanol in it. Which means it kills you. Not much. Not much, like a couple, like a sip, like a sip.
With that much kill me?
Yeah.
Okay.
On your lucky day, it would make you violently ill. If you were lucky, you might throw it up before it got enough of it in your bloodstream. Or it might only get enough in your bloodstream to cause blindness.
Oh.
Oh.
Just depends.
That's lovely.
Um,
So you can have this in schools for about 30 weeks.
What does it taste like?
You can have this in schools. for
Yes,
about
exactly.
What does it taste like?
Tastes
I
like
would like
alcohol.
sampling.
Tastes like
What if you like,
alcohol.
what if you put like a little bit, okay, not to kill somebody in like a glass of water,
Then it would kill them.
but they taste it?
Yes. Tastes like alcohol. Alcohol is a very
And then they would find it in the, like if they did a poison test. they would
Well, I mean, if
find
they
it.
already drank it, then the damage is done.
Well, yes, but
But it has.
the goal is not to get caught.
Oh, yes.
But there's a girl taste it, if you try to poison somebody,
Well, it's like
Oh,
after.
then
Why are
it
you
is
worried
like
about poisoning?
I'm not asking the important.
Okay, that one is doing something. I was
Do you enjoy the smell of gasoline?
I cannot guess.
I know you don't share anything about your friend that used to sniff it on the school bus.
Definitely.
Yeah,
I'll
it
never
didn't
forget
end well for him.
that. Never forget that story.
Said he's on alcohol death row.
I mean, that's not fun.
That's not part of it.
I'm not laughing.
I always gotta argue, can't you just get along?
Mr. Kettle, what exactly?
Yeah, the
is
lucky
it?
working.
The paper.
Okay, that one's working.
Separating into anything besides black.
No.
What does it look like?
It looks purple and purple.
I feel like that was like the one separating that shit out by attraction to the
Because it's never-
which is the
Yeah, I'd like
attraction
to
to
like
the salt,
write it on
which is
just like
the
powder it off.
Should have done.
alcohol. Alcohol.
If you do the Crayola one, it's like green. It's like very nasty green.
Grab a couple more colors of there.
So what's happening?
So what's happening here is the ethanol is taking some of the compound with it based off its polarity. So we're separating out substances based off polarity.
So that one didn't have a good color.
It had, yes, this is obviously a lot of non-polar stuff, non-polar. Not, doesn't care to go along with the polar ethanol. It's like, it goes fine. This one has some stuff that apparently wants to go with it.
It has more than the purple though.
Yeah.
Let's try this.
So the stuff that's going with it, polar.
More, yes, it's, the more it goes with the polar solvents, the more polar it is. Red. Kind of a light green, I guess. Blue. Dark green. I did.
Like, are you
62, I don't know.
Are you like Stephen and Marty?
No, just ask.
It's very, it's not, it's not enough polar stuff in there. So what we would have to do with the expo marker, yeah, the black expo, it did nothing with the ethanol, is we would need to try different solvents. Okay? Like, I bet, if I had some hexane, I don't think. Y'all watch that a minute, let me go back and see if I got it.
So like the red is like.
He did this. He turned around and said, "It's your fault."
It's your fault that it doesn't trust us around it and be natural.
Brett is definitely working on this.
Oh, what must have been for so It's very loud. It was fun. I'm just not doing this stuff like that. Yeah, but if you are, then it's fun.
Dang, right here, recently those.
I'm gonna go to the water for Cobra. That's like right beside it. Yeah, but the water one is great too. It was $50. That made me mad. It's $50 for one ticket. And it's, yeah, it's like 30.
You must
have 30 minutes. So you do. If you go back out, you're not for that. I go to 30 minutes.
That's weird.
Georgia. You gotta just make sure you stay in there.
Yeah,
And that food is so much.
No.
It was
was it good or was it?
Yeah.
It's a. Oh, that's terrifying.
Hey, for the water from Cola, it
Do
was like
anything?
$20.
Yeah, the red one.
Separating into two, more than one color though, that's what we wanted to
The blue turned into.
I mean,
green.
the black kind of looks purple.
do. Yeah. This is kerosene.
I definitely use that one.
You know this song, sorry.
Would it be like the dramatic death, or would they go quietly?
No, they probably call it.
Oh,
It's just carrot.
How long would it take?
Carrot.
How long would it take?
That's what it says.
Kerosene.
Kerosene.
Kerosene. So kerosene is a mixture of 9 to 12 carbon hydrocarbons. So this is going to be very non-polar, right? And that's not a very clean beaker, so we may be fixing it all kind of mixtures and stuff here.
Yeah, look at the bottom of it.
Yeah, we probably dissolving whatever that was too. Let's see if that'll go with it. Like I said, what you would do here is you would just keep trial and erroring with different solvents and different mediums until you got it separated.
So which one would we try after this? If it didn't work?
This is the one I got. I got a polar and a non-polar. We got one of each, so. We got some acetone.
Is there any solvent that can make it like?
Well, yeah, I'm sure, but I don't know what it is. This is called science experiment. We're just trying.
Is this what you did at UAB?
Okay, so I quit research over chromatography, honestly, true story. Okay. So one day I was separating something. I don't know what it was, and I was trying to, I labeled, we always just label everything with expo markers because it comes off in washing that stuff. So you always had your chemical, on the front, the glass front of the fume hood, you always had the chemical reaction written out, okay? So that anybody else who worked in the lab would know what was going on in there. So you turn it on with the lunch, right? Everybody needs to know what's going on. So you had that all written on the front of the glass. And then you labeled all your bottles and stuff with expo marker because it cleans up so easy. Not expo, sorry, Sharpie. It cleans up. It doesn't come off with anything except acetone, so it stays there. Anyway, somehow, I don't remember how I did it, but somehow I had this mixture of stuff, and I was trying to pour it into another thing. The solvent ran down the side of the bottle and dripped. And it dripped the Sharpie ink into my sample, which was the compound I was trying to create, separate, and was fixing to take it down the hall and have it tested. And now it's got Sharpie ink in it. Okay. So what do you do, right? it took a week to create this stuff, right? So what, you gonna start all over, or you gonna separate? So go to my boss and say, what am I supposed to do? She says, well, you gotta separate it. You need to do a chromatography separation to get the heat out. So that meant filling this kind of a burette thing. It's a little bigger than this one. Imagine this kind of contraption with a valve at the bottom, but one that's considerably larger around. Okay, and you fill this with that silica gel stuff, and then up to a certain level, and then you pour your stuff on top of it. Okay, and it'll start. Gravity will pull it down. Okay, and some of it's going to like that silica gel, and some of it's not. Okay, so as it's pulling it down, it's going to start to separate out based off. Basically, it's racing. Okay, some of it's going to like it, some of it's not. So it's coming down through here, and it starts dripping out the bottom. Right. So I've got like 3 or 4 different things mixed in here. One of which I don't want. The others of which I'm actually interested in. Okay. So is that doing anything? Okay. So anyway, the way you do this is you set it up and you let it start dripping. Okay. So it's going to take 30 minutes before you get the first drop. All right. And then after that, you're collecting these drops, about 20 drops at a time in little test tubes. Okay. And you set them aside. And you come along every so many test tubes, you can do a separate little chromatography test on a piece of paper about like this and see how many different substances. So you're going to have one dot show up on your chromatography paper for the first so many test tubes. And as soon as you get 2 dots on the same sample, then you throw that one out, and you know that everyone past that has the second compound in it. And as soon as you get 2 dots on the next one, you throw that one out, and you know everything past that's got another third one in it, and so on and so forth. And it takes hours.
This is undergrad?
No. This is doctors. This is PhD students. So drip, 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 drip for hours. Okay. So that's the day that I asked myself a question: could I do this for the rest of my life? The answer was no. But I mean, it was maybe a little overreaction because it wasn't my fault. But I had about tired of the whole thing anyway. That's pretty much the life. And some people are cut out for it, and that's great because somebody needs to cure cancer. Just wasn't going to be me.
Right.
Because I was nervous breakdown. So I couldn't deal with that. It's very fascinating how it all works. Like how that chromatography thing operates is fascinating to me, but I don't want to spend the 4 hours to do that. Just to actually do it. I probably don't do a whole lot of labs.
What was labs like in college, undergrad?
Similar to what we do around here, just you have to do it. Well, in the freshman class, you don't necessarily have to do it till you get it right. You have to basically do it till you don't just butcher it. So you get 3 hours. It's like, here, do this. If you get it right the first time, they're great. And if it's just horrendous, and oftentimes it is, I've done it before, you do it again. And, you get second year like organic and stuff like that, they expect you to do it to get right. Especially if you're in like quantitative analysis, which is or instrumentation, or reading those classes, which are literally about lab, nothing but classes lab. Then you're expected to do it within 5%. So you stay all day if it takes that long to do it. And sometimes you stay all day. Sometimes you work all morning and you still don't have it. You go to lunch and come back. Anyway, how fun. But watching things drip, 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 you're watching things bubble in a pot for days, like days. Just wasn't for me. Maybe for y'all, it is. Like I said,
Yeah.
You weren't in bed for hours. I would give up. I don't like.
You got to like measure.
Man, what I look like doing? I'll take that.
Based on like
Bye. I just take that. Bye.
I try.